think I'll get comfortable since we have this nice couch here. How's everybody doing? It's great to see everyone in person again. Been a little bit of a hiatus since we've had the Bazel cons in person, so it's awesome to be here. I'm Zach. I was formerly the CEO and co-founder of Flare Build, and now I'm actually an engineering fellow at Bitrise. And today we're going to talk a little bit about some of the work we're doing around Gradle, which might seem a little out of place at a Bazel conference, but trust me, it'll all make sense in the end. So just a quick little bit of background about how we got here to be discussing Gradle. So obviously, some of you may have heard of Flare Build, and we, like a lot of the other folks here, we're working in the Bazel space, providing a lot of products and services around Bazel. Kind of like we've seen today, this sort of a standard feature set has emerged. So of course, we offered a lot of the same stuff. So that was the remote cache and CDN for Bazel, remote build execution, build analytics. One thing that I think made Flare a little bit different than the rest was we sort of specialized early on mobile. I think in around 2018, we were already prototyping remote execution for iOS, and I even pitched a talk for BazelCon 2019 about this, but it didn't get accepted. So moving on, Flare was actually recently acquired by Bitrise in 2022, which is really exciting. We're really happy about that. And so a lot of the core folks at Flare have actually gone over to work at Bitrise. And so Bitrise is a mobile CI/CD provider, and they offer a lot of great stuff. A quick overview, if you're not familiar, we're focused on maximizing this idea of app impact, which is allowing mobile shops to have the biggest possible business impact from their apps. And of course, a big part of this is shipping quick, getting value out to end users as fast as possible. We've got about 100 million in funding so far, and we've got over 100,000 software engineers using our product across about 6,000 or so paying companies. And the team, there's about 260 of us now across multiple continents. The Bitrise platform, since this is a lightning talk, I'm not going to go super deep into all that, but it's a great platform that sort of simplifies the challenges of dealing with Mac OS compute at big scale. And we sort of, we have a lot of techniques that we've developed over the years there that just allow developers to get up and running quick without having to worry about auto scaling, AWS instances and all that kind of stuff. I'll go ahead and skip this for time. I think the thing I really want to focus in on this talk is some of the things that Bitrise and Flare are planning to do together. So I'm really excited about this personally as a big fan of Bazel, because this is an opportunity for us to bring Bazel and some of the related techniques to a much, much wider audience. Obviously, we've got hundreds of, over 100,000 engineers using our tooling, but not many of them are using Bazel. We'd like to see that change. But at the same time, we also want to work on, bringing some of the same tools and techniques that we enjoy in Bazel over to people in other ecosystems. So thinking about how we might pragmatically go about actually doing that, if we think about Bitrise on the one hand, it's a great mobile CI platform for iOS and for Android, and of course, really anything else you'd want to build on it, but we focus on mobile. And we've got 100,000 or so developers using the platform. And Flare has built a lot of cool, extremely fast cache CDN tech, remote execution. How do we, what would the product be, the first product be, if we wanted to actually, capitalize on our two sort of combined strengths? So zooming in a little bit on that, on the one hand, Bitrise has, a lot of Android users. Flare has a really nice cache system. And so the first thing that we actually decided to bring to market is a remote cache for Gradle that's actually powered by the Flare technology and just works out of the box for any Android user that builds their app on the Bitrise platform. And this is, like I said, many thousands of engineers. And so the point of this talk is really to talk a little bit about how we went about implementing that and how you might do the same if you were interested. So most folks here, of course, will be familiar with the concept of remote cache. And so this is the literally verbatim description copy pasted out of the Bazel docs. So I'm not going to read it for you. I think most folks here know what a remote cache is, but it's here in the slide if you don't. And so the way that remote caching works under Bazel, again, most folks here are probably familiar with this, but in short, we support both HTTP and gRPC caches out of the box. Custom caches and backends can be implemented via the Remote API protocol. And in general, a lot of the major CI providers don't yet offer out-of-the-box support for a Bazel Remote Cache. There's plenty of ways to integrate, but it's not sort of part of the standard feature set yet. Remote caching in Gradle, again, you can provide an HTTP backend to Gradle pretty easily out of the box. And of course, the Gradle Enterprise Cache node is available for Gradle Enterprise users. But it's actually possible to implement a custom Gradle Remote Cache by implementing an abstract class that ships with part of the Gradle core. And that's actually the route we took to implement a custom client that knows how to speak basically to the remote APIs. So looking a little bit into the implementation, I would like to have had time to include some code and walk through some of the logic a little bit more in depth, but we're just gonna keep it super high level because we've only got a couple minutes here. So why would you want to do this? Is probably the first question we should ask ourselves. Why would we want to use a Bazel backend to power a Gradle cache, or Gradle build rather? And the answer is, of course, sharing the infrastructure. If you're already setting up big distributed storage systems to power your Bazel builds, of course, it makes sense to reuse those for Gradle, especially if you're a mobile shop that might have iOS using Bazel, Android still using Gradle. Sharing this infrastructure is quite nice. Speed, I think that a lot of the Bazel cache backends are pretty highly optimized these days, at least on the Flare side and of course some of the other vendors. So I think the speed is definitely worth noting here. And then the big bullet for me is the availability of managed offerings. So one pain point we hear from a lot of customers is dealing with self-hosting Gradle Enterprise Cache nodes is not great. Operating that infrastructure comes at a heavy cost. And there's lots of managed offerings out there that speak the Bazel Remote APIs. So that's another nice to have here. So what's great, the Bazel Remote APIs, of course, can be implemented really easily on both on the client and on the server. That's awesome. Gradle, of course, can also be extended using the abstraction I mentioned before. That makes this a pretty easy problem to solve. However, what's not so great, the Bazel Remote APIs are actually a little bit harder to use from other tools than you might think. This is because Bazel writes action results to the action cache, and then the action cache points to blobs in the content addressable store. You can't necessarily just use these systems as an arbitrary key value cache, which is something that we needed to work through. So also the Gradle's cache abstraction only defines two methods, load and store. And these are, like I said, not really directly compatible with the Bazel Remote APIs because, again, it's not just a key value cache that we can arbitrarily put keys and values into. So to get a little bit more technical here, the way that you would go about creating an abstract cache implementation in Gradle is, of course, create a new Gradle plugin project. You have to wire up the gRPC code gen, maybe vendor, or get the API, remote API protos somehow. You would add a new cache implementation class that, of course, inherits from Gradle's abstract cache, and then plumb it into the various config files. And then really you just need to implement the load and store methods. And these would be, calling the gRPC methods on the remote servers. But the question really is, what exactly do we call? And so there's actually some kind of hacks we had to implement in the short term to make this work. So for the writes, Gradle has a function called store that it calls whenever it needs to store stuff remotely. And so, step one is fairly obvious. We compute the content addressable store resource name and just write it up to the cache. That's really straightforward. What's a little counterintuitive here is if we want to read this, we actually don't know how to recompute the resource name. So we actually need to store a fake action result in the action cache that is pointing to the blob that we wrote in step one. And so we kind of are creating a fake pointer in the action cache that we can fetch later to tell us where our blob is. So this is not ideal, but it's really the only way that we could easily write this stuff into the cache. And so then, of course, on the read, again, we can basically compute the fake action digest. We call get action results. We pull the fake action digest down, action result down, and then we again, use that pointer to go find the actual blob in the cache. So what kind of isn't great here is every time we call read or write, we're actually calling other read and write methods on the cache. So there's a little bit of latency, a little bit of overhead. So the nice thing here is we can actually implement a support for a Bazel backend directly in Java in a Gradle plugin really easily, but it comes at a cost. So this is how we started out. We actually considered open sourcing this project, but because it's not really optimal, we've kind of held off on that in the short term. What we ended up doing was actually creating a new gRPC protocol specifically for the Gradle Cache use case to avoid the overhead of those extra reads and writes back and forth. Of course, implemented support for that protocol across our whole stack. And so this is, of course, how this works over at Bitrise now. So this functionality is now in beta. So any user of Bitrise can basically get a really, really fast, performant, and stable and managed cache backend for Gradle, just directly automatically integrated in their builds, adding, of course, some nice performance improvements there. So that's pretty much it for my speed run. And thanks to, of course, all the organizers for everything here. And thanks for listening.